To introduce Molstar, I'll assume all of you are at least familiar with the principle of molecular visualization and are probably aware of a few existing tools already. Perhaps the most well-known software programs are the desktop-based ones, such as PyMol or Qt, that is, ones that are locally installed. Now, these often have powerful features such as elements of refinement or docking, but lack full web integration. On the other hand, there are a number of web-based tools such as JSMod or NGL, and whilst these can be embedded online, they often have very specific functionality, and without the power of local hardware, they can struggle to display larger structures and volume data. Therefore, it was with the idea of resolving these two conflicts that Molstar was developed, to provide a molecular viewer that was easy to use and suitable for embedding online content, but which could also be used to explore aspects which are typically more computationally demanding. This last challenge was tackled from a few directions, and now, as I'll show later, we also host specific data servers which can be used to serve both coordinate and volume data in a very precise manner, so as to be efficient with data transfer, data passing, and data processing as possible. I'm pleased to say that the Molstar development has been and continues to be a collaborative effort. From the beginning, Molstar has been co-developed between David Senno of PDBe and SciTech and Alex Rose at the RCSB US Protein Data Bank. And then with the scope for site-specific integration, our own Mandar Deshpande has joined the effort with a view to incorporating Molstar into PDBe's online content. In terms of features, Molstar was designed to provide ready access to the most common visualization aspects, like molecular representation and coloring, as well as overlays of biological assemblies or validation scores, and for comparing atomic coordinates to their corresponding volume data. There is, of course, the ability to pull structures directly from the PDBe with an entry accession code, and you can load local structures for visualization as well. There's also many advanced options to dig through, such as occlusion and other lighting effects. And thanks to the magic of WebGL, the images you create can be exported in high quality in next to no time, without costly operations such as ray tracing. Lastly, it's worth quickly highlighting that I've actually been able to embed Molstar directly into today's presentation using an iframe component on the slides.com presentation website. Technically, I couldn't find a way to do so with Microsoft PowerPoint or Google Slides. However, I thought it worth mentioning quickly, as in the past, I've spent a lot of time looking at ways of incorporating 3D structural data into my talks.